Okay, so it's the exact time. I think we can start. Hello to all of you. I'm Corneliu, the co-founder of Arcan, and I'm gonna present you the mapping tool we've developed, why we did that, and we'd be very happy to get any feedback from you and suggestions, so that we can improve it. So before that. I'll tell you a little bit about what we do at Arcan and how we came up developing Pyrog. So you all know about the lack of interoperability in healthcare, but depending on where you come from, things are more or less advanced. So here's what happens in a typical French hospital. You have roughly 100 softwares that were built independently, but that need to communicate with one another to exchange data. And how is it done? Well, each of these software stores data in a proprietary database, in a proprietary format, but they exchange messages through HL7v2 or even through FHIR. But even though you exchange messages with FHIR, you still don't have a simple access to data. It's extremely complicated to dig into these databases and to access the data itself. And what typically happens when a hospital needs to extract data is that it needs to call the software provider and to pay for an extraction, and then you spend a lot of time manipulating the data, putting it in a nice format so that you can analyze it. It's also extremely costful because when a new software developer arrives in a hospital, he or she needs to plug into different sources so that his or her software can run, and it leads to a high barrier to if you want to deploy anything. And also, and that's something very important, there's a huge lack of governance. The hospital has very little sovereignty over the data it collected because it cannot access the database by its own. And that's something critical when, for instance, some software provider disappears. You have cases where it's too expensive to migrate the data, and you have years of medical records that disappear due to this lack of interoperability. And a metaphor that we like, and I'll come back to it, is to say that things happen a little bit like in the old times when we all had our old phones, and everything depended on everything. When you wanted to install a game, it depended on the version of your phone, and well, and things didn't work that well. And now these have changed in pretty much everywhere in all industries. We work with APIs. In healthcare, it's still complicated. And there are some striking figures behind this. In France, you have the patient care. You have 30,000 people dying each year due to adverse drug events, and most of them are related to a lack of communication between services. And why why there are lack of communication? Because the data is stuck in these proprietary databases. It costs roughly 30,000 euros when you go to a new hospital to deploy your software, and that's a very high barrier, and that's partially the reason why half of projects don't go to production. You can have a proof of concept that you've built on a data extraction on a huge CSV file. Everyone is happy about it, but at some point you realize that plugging into to the production database is too expensive. And the last thing is the time we all spend cleaning the data. This job is done by everyone, every time, and it's really annoying because it could be done once and for all. So, what is our goal at Arcan? Our goal is to change the paradigm of data storage in hospitals, and what we do is that we take these proprietary databases, we map them onto FHIR, and then we integrate them into a FHIR server. It's a lot of work, but it's worth it because once the data is in the FHIR server, it's clean, it's accessible, and you don't have to do this kind of data cleaning every time. And so what we are gonna discuss about today is how we do the mapping. When I say that we store things in FHIR, there's gonna be a presentation tomorrow done by Florian to explain what it means. But once you're here, if the data you have in your hospital is in one server in the hands of the hospital, first the hospital has full sovereignty over the data, and then you have very low deployment costs because you can just plug and play your softwares, and that's pretty much what happened with the smartphones. We all agreed that we would have a common platform, which is the iOS or Android, and now software developers can focus on their product and just build the interface and the useful features. They don't have to worry about what happens in the back, and things work much better now. You just download whatever you want from your app store. So, something important to state is that we are an open source company. Everything we do is open source, but we still have clients. So what do? We integrate the data for healthcare facilities. So that's a service. We dig into the databases. We map them onto FHIR, and then we process to the integration. For software providers, we provide an API which aims at reducing their deployment cost by an order of magnitude. And then you have the once you've standardized the data in several places, you can use this as a network of hospitals. There are several things you can do on this network. You can share data within hospitals, and for instance, having something that goes from EHR directly to EHR. But you can also train models, which is very useful for AI companies or pharmaceutical companies that now have a very hard time accessing data. And something very important is that what we do is always keeping the data on site. And one of our co-founders is also a lead developer on OpenMind, and we put in place a method of federated learning. And maybe some of you saw the presentation by Thomas Walter yesterday morning. So he's from. I'll come back to it in one slide. He's a co-founder of Lumio, an AI company, and with them we develop a tool to train a model on different sources. But we never gather the data. We send the model training once here, one there, and the only thing that moved from one hospital to the other is the weights of your neural network. So only the statistical correlations within your data and not the data itself. And so, what do we build exactly? Well, the first thing you need to do is to map your old database to FHIR, and that's complicated job because these, especially for old softwares that have been here for decades, the database schema is very complex because usually you can only add up in complexity. You can never remove tables or remove columns because your software is already deployed and you don't want everything to crash. So if you want a new feature, you add a new table, and you can end up with tens of thousands of tables. And in order to do the mapping between these tables, also, we're talking about relational databases. In French hospital, it's mainly Oracle, but for Postgres, MySQL, and etc. So the first thing you need to do is to map from this to FHIR, and that's what Pyrog does. Oh, and by the way, yes, everything we do is open source. I put here the name of our repos if you're interested to take a look at it. Then once you've established your mapping rules, you know where to put each piece of data. You need to integrate it, and that's what the FHIR pipe does. It uses the mapping rules and proceeds. It's an ETL, so extract, transform, and load. For the transform, we need the mapping rules, and for the extract as well. And well, that's the job of FHIR pipe. Then we store the data. well, I put here a native FHIR storage. What it means is that the model of our database mimics the architecture of FHIR. So it's a MongoDB database. And Florian Bion, who's one of our open source contributors, will present this tomorrow in the afternoon. The reason why it's interesting to store things as close as you can to FHIR is when you want to run massive analytics on your data and you want to access bulk data. It's not enough to have a REST API. You'd like to query the database directly, and it's much easier if it mimics the FHIR format. Then, well, since we've developed our own server, we had to develop an API on top. And something else we do, which is maybe more about marketing than about the technology itself, is building a few demo apps which can be plugged directly in on this FHIR server. And the reason for that is because when you go to a hospital, you need to have something to show, and it's quite easy once you've integrated data and you have everything just to develop some very little tools that make a big difference when showing what we do. And the way we see that, it's exactly so. If you remember the metaphor about smartphones, it's like the apps that are pre-installed on your iPhone or a smartphone. You already have a messaging app. Maybe you'll install a better one. For sure, you'll get WhatsApp at some point. But it's important to have a small store of open source apps. Otherwise, you won't buy an iPhone. And then there are the network access and federated learning methods. And Thomas Walter presented something yesterday morning about that, what we do with Lumio. So the specific use case here was to predict the length of stay of patients in order to detect detect some complicated cases and to better redirect the patients. And it's a very interesting project because things like that have never been done on, as far as we know. There are projects, but there are very little results about real life data from EHRs, mainly because of the lack of interoperability. And these federated learning schemes have been applied successfully in other use cases, but not to that. And so the goal is to use the data from 3 different hospitals to have a better model. And when a patient arrives at the hospital, to be able to tell how long he or she will stay, to detect the weak signals, and to have a better management within the hospital. And well, the presentation is done already, but Thomas will be very happy to discuss it with you if you're interested. And so, Pyrog. What Pyrog does is that it maps relational databases to FHIR. And now, so I'm going to do the live demo I talked about. I think everything will work fine. If it doesn't, I have some screenshots, but it will be no, that's great. Everything is on our repo if you're interested. And so let's go. So, what do we need? We need to map an SQL database, well, a relational database, to a FHIR model. So, conceptually, what we need to do is pretty simple. We need to target the right columns and put them at the right place. What's complicated is that we have a lot of columns, that we have to do joins, that we have to run cleaning scripts, there is some work. But the third thing is target this and put them into FHIR and have this kind of conceptual map. And there are a lot of ETL tools. You could do that with Talent or with something else, but it's not. So at Arcan, we'll only be mapping things to FHIR. It's very useful to have something which is purposely designed for FHIR. And especially when you go into profiling and things like that, it's quite complex with the standard tools. They are too standard to fit the requirements. So we need something which is FHIR friendly, which is user friendly because this was designed to be used by the entire community, and especially would like this to be used by practitioners. Well, maybe not the practitioners, maybe not all practitioners, but in a hospital, you typically have a few people who know the database very well, who can code a little bit, and who could use this tool and maintain it, because the database schema you have, it will evolve, and the hospital should be able to change some mappings by hand when they implement a new questionnaire, for instance, or things like that. The very interesting thing about this schema you have here, so this is a screenshot from Talent, is that you see what happens. So it pretty much works as a documentation, and what we need is our tool to have a documentation as well. So let's see it. Here is Pyrog. So what I'm going to show you today is a partial mapping of Mimic. Mimic is an open database that is published by the MIT, and it's the record of an emergency department from a hospital in the US. It was initially built by Philips, and you need some authorization to use it, but here is only the demo version. So this is my source Mimic. I'll show you how you can add new sources. But what do we have? So, not very handy. This is patient. Yes. Okay. So let's take a look at it. Here, on the left side, you have your FHIR data model. So the resource patient, it has a lot of things. It has identifier, it has a name, it has. And now we are on the attribute deceased date time, so time at which the patient deceased. What we need to do is find the right column in our database and put it here. So you see the little tick, the green one. It says that it has been mapped. And what are we saying? We say that the deceased date time is in the table patient in the column date of death, DOD. And well, the reason why you can use that as a documentation is that it's built in. You just look at the green spots. You see what operation you've done. It's a record. It's a you can see what you've done. It's not just code, and it's very easy to use. So let's try to map something. What do we have here? Birthday, yes, it's correct. So, birthday, the date of death, yes? Ooh. Welcome. It was in the table patients. Well, should be in the same one. Well, of course, you need some knowledge about your database, and we'll talk about methods for exploring the database, but up. Here, the nice thing is that Mimic is locally on my computer, so I have a few lines that are extracted, and here, it very much looks like DOB is the date of birth compared to DOD, which is the date of death. So let's put it. Date of birth, and we added it. We have the little green tick. We can move to the next resource. Yes, of course.
About the date of death, basically.
Hmm?
Can you have also logic in this mapping with DOD, DOD hospital, DOD SSN to have some kind of rank ordering in terms of, okay, if that one is present, this is better than that one, than that
Yes.
one. Can you do that also?
Yes, exactly. I'll come to it in 1 minute. If I forget, please ask it again. Yes?
Another question. So, what version of FHIR do you use in this FHIR mapping? now like new, will kind of like R5 or whatever, and so okay, is it?
Okay. I'll come to that in a bigger moment. What you see here is the standard FHIR profile, the one you can download from the FHIR website, the most basic one. But if you have questions, please don't hesitate. Maybe I won't come to everything in a minute. So it's FHIR friendly. It works as a documentation. We'd like to have cleaning scripts. Before, what we are saying is a bit more complex, but the first thing is I want M and F to be mapped onto male and female, for instance. And what we'd like is these cleaning, what we choose is to use Python for these cleaning scripts, because if you want, we found it was the right balance between developers and practitioners. Something pretty much everyone could use or learn, and that's why we choose to implement it that way. So let's see. I like a script to clean my date of birth. Do I have one? I have clean date. But what if I don't? Well, if I don't, I can add one. Here I have the list of scripts. And if I'm not happy with that, I can implement another one. Well, you got the idea. So this is it's quite basic at the moment. What it does is that it checks. You have something to check that you do the right thing, and then it is your script is pushed to your GitHub repository. You could also choose to leave it local. It's as everyone prefers. So, cleaning scripts, we can do that. But what you were mentioning before is something a bit different. Is what if we have data from multiple sources? So let's say that there might be a column, date of birth 2, for example. I'll just put some random things, but you see here that you have merging script. So with a cleaning script on each row and a merging script, you can do pretty much anything. So for cleaning the data, we should be good with that. Then we work with relational databases, so we'd like to be able to make joins. And typical example is something you can find in hospital databases, that you have for the address. Each country has an ID, and there you have another table with all countries matching the IDs. So you'd like to run a simple command, select country lab, and do your join. And this is something we need to implement. And you do it this way. You can add joins between one table and another, which immediately raises a new question. How do we instantiate our resources? When is a patient created? First thing. And if I have several tables for observations, for instance, there are many tables that should pop up as an observation resource in FHIR. Maybe I'll have a table about blood pressures, a table about glycemia, and I'd like all of these to instantiate an observation. So how do you do that? And I'm happy you didn't ask the question yet of how do these patients are generated. Well, here. What we say is that we have a table listing the patients. Every time there is a new subject ID a new subject ID in the column subject ID, we'll create a new patient. That's how we instantiate stuff. And if we want to build several, here I have a resource, observation, to which I put a little tag, blood pressure, just to remember and to have it written here. If I want to put another one, observation is right. Yes. I create a new observation. Oh, it's in French. I'm sorry. And I can I can modify the label. I can modify the primary table, and etc. So that answers another question. Do we have another one? Yes, database exploration. As I said, there are a lot of tables, and you'd like to explore a little bit. And you saw that we have the first, when we select the table, we have the first few lines, which are very helpful if you, well, you could do this with a separate tool, but it's handy to have everything within the same interface. So here, my database mimic. I have everything that I need to set the access to mimic. I have the port, user, and importantly, the database type. Yes?
Does it support like mapping from multiple sources? Because commonly you have like 3 systems. Here are the patients, here are the next the same patients but with another ID. Here are the same patients but with some additional and whatever. So you need to aggregate. And
yes, exactly. So let's come back a little bit. This schema here is not true. We won't put 3 databases directly into the FHIR server. What we will do is integrate this one into a temporary FHIR server and then merge things or query directly. But you don't want to do everything at the same time. You wanna have an intermediary steps here with 3 small FHIR databases. But this is not the job of Pyrog. What Pyrog does is mapping one source to FHIR. So we'll have to do this job 3 times if you wanna integrate more. And yes, so I think it's pretty much all for the demo. Oh no, I told you that I would show you how to add a new source. Do we still have time? Yes. How to add a new source? Good. Let's come back to the sources. You name your source and you add the database schema. Well, actually, the list of lines and of tables and columns. Sorry, you upload a JSON file, which is used to generate these. They don't come from. They have to come from somewhere, and that's where you feed them in. Okay, so how do we store these mapping rules that we've established? Well, we store them in a GraphQL database. Why do we do this? So maybe you have the question. We'll come back to this in a moment. Why don't we use the FHIR resource structure map? Because we found it complicated. We were not sure we could get to the end using structure map. That's something we're thinking about. If you have advices on this or if you want to contribute, we'd be very happy. But also, we very much wanted our clinical scripts to be written in Python, and as far as we understand, it's something that is not supported yet. And well, something we can discuss. So, how do we store all this? We store them in GraphQL, and if you don't know, GraphQL is something very interesting. Well, it was published by Facebook a few years ago, and it allows you to do graph-like queries on your database. So, what is our data model? So, what we want to store is several sources. So here, mimic. A source has several FHIR resources, a list of resources. So here we have patient, observation, etc. Within each resource, you have attributes, the gender, the date of the name, all the FHIR attributes. And within these attributes, you have input columns, the one we were clicking on. You have scripts, And within an attribute, you can have a list of attributes because you can go deeper into the FHIR graph. And so it's not the actual data model we use, but it's a simple version. But what's very nice is that we tell this to Prisma. We tell Prisma, here's our data model. You just write this in a file, and then everything is handled for you. The graph is generated, and you can start doing things. And the very powerful thing is the way you query this first. So let's try another live demo. So here I'm on my my graphical playground. Here, what am I querying? I say, look at the source mimic, and show me its ID, its name, its resources, and within these resources, the FHIR types. And that's what I get as a response, a JSON. But I could do more. I could say, oops. Tell me if I make any mistake, please, because up, and let's make this a bit more pretty. So now I say, within these resources show me all attributes, their ID and their name. And poof, I get the IDs and the name. And you can really like write your query. It's very custom, and it's very high level. So it's.
How come we don't see two observation resources? In our model, I thought we had two different ones: blood pressure and observation 1.
You'll ask for. So here you say resources is the list of all resources. And if you want something more specific, you'll query the specific things you wish.
In the mapping that we built earlier, we had two
Yes.
different mappings for observation.
Yes.
How come those don't show up as two results here?
Okay. So let's remove this. Otherwise, we'll have too much. Oh, you're right. We should add a label here, maybe in the data model. Or maybe there. Okay. This is the FHIR type. Oh, okay. No, this is just the FHIR type. So they have a FHIR type observation. And I must admit, I don't know the data model enough, but there should be attributes to distinguish them, for sure. Otherwise, GraphQL wouldn't let us put them in. But so FHIR type is just the type FHIR puts on it. It's very handy, and you can export your mappings as the JSONs, and you can manipulate it as very easily. So it was interesting for us. Well, that was in case it wouldn't work. And what is next? There are still some features you'd like to add to this. The first thing you realize when you start using it in practice is that you click a lot. You click, and at some point you get bored about clicking. And what we like to implement, so here it's a very early version, is an SQL parser, because usually if you know your database a little bit, you already have some commands that you'd like to copy paste instead of everything. So something like this, and it would automatically generate an SQL. So this is the SQL request. It would automatically generate the right queries to the GraphQL database. And we'd like to add joins and things like that, so that you don't have to click too much. What more? Profiling. There was a question about this. Right now, the graph, the FHIR graph you have on the left side is you have to generate it yourself. You have to feed in Pyrog with the appropriate JSON files that you build by yourself. It's not very handy and what you'd like. So the way this image was done is by taking a screenshot and adding the logo of simplifier.net. But something which would be very nice is if you could download your profile directly from Simplifier when instantiating a new resource. Then mapping suggestion. So here we have so this screenshot was taken like 1 year ago. There's a new version of it, but it has no graphical interface yet. It's Pagay on our repo. And the goal of this is to give suggestions for the columns so that you don't have to do all the exploration by yourself. And how can you do that? Can do that with a mix of deep learning and some decision-making rules. You have a pre-trained neural network that can recognize names, codes, dates, things like that, and it looks at the type of the FHIR resource you're trying to map. It is a date, so it will only suggest dates, and we'd like to augment it with some so that you can type something that it would rearrange the suggestions based on the name of the column, if you can guess it, and things like that. This would be very handy. And this is the thing in gray here that you cannot click on because it's not built into Pyrog yet. And last thing, using structure map, we'd like at some point to have a version of this because we're trying to make things standard, and it's not that standard to store it in GraphQL. It could be directly in FHIR, but we feared we might lose some users and part of people who could be interested in Pyrog if we made things that complicated from the beginning. So at some point we'd like to migrate to structure map, but we don't have a clear roadmap on this yet. And some last words, because we're almost done. So we are 7 people at Arcane, and last week we've opened a new position for developers, so if you're interested. But more importantly, everything we do is open source, and if you'd like to contribute or to discuss the project, we'll be very happy to onboard you on what we're doing and to have you as contributors. And well, if you want to see the first 5 slides exactly the same, said a bit faster, you can come to the startup track where we've been selected. But more importantly, Florian will do a presentation tomorrow afternoon about how we store things directly in FHIR, so the MongoDB database used as our FHIR server. And Thomas Walter from Lumio Medical did this presentation on federated learning on FHIR, and it's very interesting to discuss with him, and they do a lot of nice stuff at Lumio. And I think I reached the end of my time, so thank you very much for your attention, and if you have any questions, don't hesitate.